We're going to go ahead and get started. This is Brian Douglas. He's here to talk to you about training AI on your own code. I am going to be listening intently because I would like to know how to do this. Round of applause for Brian.
Ooh. All right, I gifted you light mode. All right, good morning. I'm Brian Douglas. I go by B-Dougie on the internet. You might know me from the internet. I used to work at GitHub for about 5 years. I've been on their content and stuff like that for a long time. But as of recent, started this new company called Paper Compute. I have nothing to sell you. I'm just here to talk about some open source stuff that we've been doing the last couple months. And really, if you guys talk to us up at the booth, so we have a booth upstairs in the expo hall, you kind of got the earliest version of this. And I'll go through some other details. So this should be a speed run. This is not a workshop, so don't expect to like step 1, step 2, step 3. I'm gonna just share my journey of how I learned this. I'm more than happy to talk. Actually, I have a blog post on this that has step 1, step 2, and step 3, but I'll share that later. Cool. I'll start with Pokemon. So who knows what Pokemon is? Okay, excellent. So I am an elder millennial. This came out when I was a kid on the Game Boy. It was a big deal. I spent a lot of time playing Pokemon Red. And I will show you, this will all make sense eventually, but I'm gonna show you how to speedrun Pokemon and how I sort of navigated that, and that's what kind of led into sort of training AI on your code. So actually, and also prefaces, this also banned me from Claude as well, so use it at your own discretion. So, case study, there's a Pokemon game, Game Boy, Pokemon Red. I read a paper, and I'll talk about this paper in a second, but I wanted to be able to like test out some of the stuff we were building in open source. One of the things particularly, if you went up at the booth, called Tapes, tapes.dev is a way to capture agent sessions. And I wanted to basically validate the stuff that we were doing at scale, so like an intense amount of scale. So the idea here is I wanted to basically speedrun Pokemon to capture 1,000 turns per session, and then each session is basically an epic. And then every time I ran through a session, I would actually capture that data and then go learn. And that's what starts to sort of self-healing loop. So wanted to actually preface this because it actually leads into a bunch of stuff that I'm gonna talk about soon. But the idea here is that we have these two things at Paper Compute, open source, GitHub repo. One's tapes.dev, and we spent a lot of time upstairs talking about turning your dead tokens into skills using tape sessions. But the thing we didn't really talk about was stereos. And stereos we're not really chatting about here at the conference because if you're interested and you have that problem, like we could talk to you about it. But most folks are really just like running agents on their own MacBook, or if you're really, really skilled, you're probably using a cloud environment or a sandbox. But like we're all kind of just learning. We're pretty early around the trajectory of the curve of inflection. But stereos, it's a runtime for agents. So like a sandbox, but actually batteries included. Cool. So disclaimer, I'd mentioned this earlier when I started. I have nothing to sell you. This is all stuff that's been open source within our organization. So the only way you can pay us is through a 5-star rating in the review. I don't know if we're doing reviews at this event, but I'd appreciate that. Oh, we are? Well, there we go. Bottles of water at the end. So this is a setup that I have for Pokemon. Again, bear with me as I explain this because this all connect. Pokemon is a game. You start as a kid in your house, you wake up late, and you have to go to Professor Oak's cabin to get your first Pokemon. So I thought, hey, if I can like use a couple things. So PyGameBoy, which I didn't actually explain a couple slides ago, but PyGameBoy is a Python library that you can play Game Boy emulators in games. So if you want to go deep in the lore, like you can have ROMs. These are games that have been flashed that you can then play on handheld devices or on your computer. And with PyGameBoy, you can play any Game Boy game headless. So meaning I don't have to watch it play. I can just let it run like through an agent. So then that kind of unlocked, and I was like, cool. Well, I can use Claude Code or Codex to basically run PyGameBoy because Claude Code is just a harness. Claude Code it says code, but it's a pretty general purpose harness that you can do almost anything with. So I ended up doing this in a sense of like, I knew I wanted to run the agent, 1,000 turns, but I also wanted to record those sessions to identify the learning patterns. So then every time, if I got blocked or if I hit like couldn't get over a bridge, that would get recorded. So this is actually this is actually screenshots of the game playing. So what I did is every 10 turns, take a screenshot. So that way the agent can always go back and learn to find out what happened. So when you get blocked, you can identify this thing is like, this character is just not quite getting to a conclusion. And my only conclusion was 0 to Pokemon. So it's at the very beginning of the game, you start, can I get to Professor Oak's cabin? There's no battling, there's no conflict. It's just get there, pick a Pokemon. And I just wanted to get to that point. But the challenge is I ran this like for hours and it would not basically get to anything. What I found out is I forgot to tell the agent to talk to people in the game. Because one of the first context clues in the game is talk to your mom. And your mom will tell you exactly where to go. But an agent would have no idea. So one of the rules I actually had is I can't use the internet to go learn how to play Pokemon. It has to be self-learned within the ecosystem that I'm giving it to play in. So the agent wasn't learning, it was just politely hallucinating progress. It would actually celebrate wins of like, hey, we finished 1,000 turns, we did it. Absolutely right, you guys know that from Claude. It would basically just do this, and this is back in February, so yeah, this would have been like 5.4 codex and like one of the opuses. But what I'm getting at is like, this was like a nice construct for me to take that context and then go serve it back to the agent. So a lot of folks we talked to upstairs, they're like, they have a skill where they kind of sit and look at their sessions at the end of the week and then they summarize like stuff that's been done. Good for you, that's great. Like you're definitely like top notch when it comes to like using agents, but I don't do that. So instead, I just dump all the context into a tapes database. So at the time we were using SQLite, we've actually moved on to Postgres for limitation reasons. SQLite has single player methodologies, so only one person can write to the database. This setup was actually 10 Pokemon agents running simultaneously, 1,000 turns each, and learning and constantly feeding back. So I have the tapes database, which is all the raw data. So this is the log for agents. And then I have this memory folder that I would start, there's this concept from Master. I wrote a blog post around observational memory. And this is like taking your 1,000 sessions and then writing an observation. So think about the end of the day, you open up your journal and you're like, man, I saw this amazing talk from Brian B. Douglas from San Francisco, California. It was amazing. He had a great shirt on, his glasses. I'm just kidding. I don't know if you do this at the end of the day, but like these are observations at the end of your sessions. I was just dropping these in Markdown. So these get written by the agent, but the agent gives me human readable feedback. So things like when I found out, oh, the NPC has no idea, like we've not talked to any NPCs. We have no context of the awareness of the entire world. We should build that into the loop. And then I also had this observer state JSON. This is something I actually discovered later. And this is very specific to Pokemon. Like this could live something different in your code base if you're approaching this, and I'll show you how to do that. But it's like up, down, left, right. So like you go up 2, you go out 1. The things I actually learned through the observer is that when you go through a door, it takes 7 seconds for a cooldown because you can't spam back and forth through caves. If anybody's played like JRPGs or any sort of games, no, yes, no? Yeah, so like you just can't spam back and forth and like refresh and like go like level up and kill a bunch of enemies that way. So that was something I actually learned through the Observer MD as I was like looking at the doc and then would chat with the agent, say, hey, okay, well, we got here, what's happening? Like, what do you think? Like, let's chat through and use like a Socratic method to get out of that loop. So this kind of concludes the Pokemon section of this talk, but this is all live on Pokemon Kafka. I actually did have 10 simultaneous agents also record through Kafka and then capture anomaly detection. So a lot of the anomalies of like not going through doors. Actually, when I got to the point of battling, that was like some weird anomalies of like, okay, when you're below a certain HP, you should probably eat a berry or you should probably switch Pokemon. There's like a lot of nuance that I had to like have the agent learn about the game. And I guess all looking at me like, man, Pokemon is too much. But the goal was I ended up getting to the point where I can viciously get a self-healing infrastructure loop to eventually get the 3 seconds to Pokemon. So game starts, spams the A button, and then A is the name of the character, A is the name of the Pokemon, and the speed runs to get the Pokemon from Professor Oak. But at that point, through the observer, I ended up figuring out that you don't hit A when you pick your Pokemon, you hit B, because they ask you yes or no, and you had to hit B to get out of that. So it's just a lot of like nuance, but again, like we think about our code bases, think about stuff we've been shipping for like 15, 20 years, maybe less than that, 5 years. Like there's a lot of nuance that we know about our code base, or maybe we have learned in complexity that we've created of the code base that you kind of learn on the fly. But lately, we've been basically just like shooting from the hip And this like, we've got new, every 5 hours you get a refresh on Claude session, so we're just going live next. Like, we got refresh, we got more token window, let's just go. But we never learned from the last 5 hours of sessions. And that's what kind of leads me into this like brute force discovery and like massive learning. So it's a great way to like understand a code base, to go search and grep, identify files that you should be understanding. Things like writing a blog, like I like writing blog posts about code bases I don't know. It's like one of the more fun investing things that I've been doing. And it's mainly, I'm not gonna write this code, but I do need to know how this code works. And I need to know how to like navigate this and like discuss it with engineers. So what I ended up developing is like a cheap simulator to identify like some of these best practices that are coming out of these like Karpathy papers and stuff like that. So I encourage you, like it's open source, like take this, run with it. If not, go play a different game. But what I'm getting at is like we are now in a place where we're all leveraging AI. We're all here at this conference. Like you didn't pay for a ticket because you weren't using AI. Or if you're not using AI, like you should probably sign up today and then catch up in one of the workshops. But Claude Code stores your sessions, Codex stores your sessions on your machine for 30 days. After 30 days, it's deleted. So as I walk through all this like Pokemon navigation of like infrastructure and learning, like all those sessions are also on my machine because I use Claude Code as my harness. But the value is all being lost because we're just moving on to the next 5 hours and like the next window or the next day or the next month, we pay the next $200. I guess you pay £180. Is that what the price is? Did I convert that right? But what I'm getting at is like, we're paying for this and we're just renting the tokens and then we get no output from it. So there's a lot of opportunity for us to figure this out. So all the Pokemon turned into what I call sweeper agent. So sweeper agent, I thought would be funny to say that out loud, sweeper agent, but it goes through a code base and this sweeps through. So I had a bunch of code that I shipped last summer when I was vibe coding and I never touched ever again. So I'm like, oh, I've got a lot of the garbage code. What if I went through and like just linted it and like massively fixed a bunch of stuff? Or what if I ended up like setting up like 10 parallel agents to just write documentation or create a context, like a bunch of specter of a development context so that the next engineer can figure this out. So that's what sweeper agent is. And it basically takes like separate VMs, which is stereo is what I talked about earlier, but then also each VM has a tape session being recorded. So then I have like now 10 tape sessions of data that I can now have to one, generate skills, but also generate documentation, generate context. I'll get into a sec about fine tuning a model, but this is a massive amount of data. And if you're working at an enterprise or a company and like you're paying for this stuff, you should be extracting value. I know some people are in a position where their company is specifically, they have a deal where their data is being trained by Anthropic. So you get a huge discount. Like I work for Anthropic, but if you want to give the data to Anthropic, like they'll give you a discount. But that's expensive. That's really good data. Cursor currently is in a deal for $10 million at minimum with SpaceX. Like that's the high point. I've actually been working with a lot of AI companies in the last year. People are selling your data. So if you're using, I don't want to name a bunch of companies, but like they are selling the data because it's expensive. So you should collect it yourself, and you should do something with it. So that's what I'm here to say. So Sweeper is also open source if you're interested in taking a look. There's a blog post on both the Pokemon and the Sweeper agent stuff. Highly recommend, just take a look at it. The one thing I'll also say is like the agents, they don't always need a better model. So like we've got Opus 4.8 as of like 2 days ago. That's great, it's working pretty well. It's better than 4.7 apparently maybe, I don't know. Who knows, we're past performance is not predictor of future growth, but sometimes you can use the cheaper model for certain things. So like when I talk about Sweeper agent, I can use Haiku at scale with 10 different agents, and I can crush that because it's a very bespoke, like rudimentary up, down, left, right type experience. So now I have an opportunity to like use a cheaper model and have to get the job done. Maybe it takes longer, but like if we're using backward agents and run this stuff over the weekend or overnight, like none the wiser. So this is, I failed to get like a really good image, but like at Paper Compute, like we capture traces. And the beauty of this, if you ever like took your school book and wrote a little picture on the bottom corner and like had like a little stick man and you like fold it, like you kind of trace back and forth and you have this cartoon. Like this is kind of what we're doing with all of our sessions. Like we've figured things out. We've like innovated something, whether we wrote the code or the agent wrote the code, we've innovated something that we should keep as a novel concept of like we should share and transfer that knowledge. And I also want to mention that as I was exploring this a couple months ago, the same week that I finished the Pokemon thing is the same week that the auto research repo dropped. So everything I explained is basically this. Karpathy has a repo about auto research. Qwen 3.6 has auto research built into the open weight model. So it's a concept of self-healing, and the self-healing infrastructure exists already in a Chinese model today from Alibaba. So I say all this because I did get unblocked from Claude. So as it reminds you that Claude did block my account for running 10 parallel sweeper agents. Turns out if you write a blog post and then email them and say, hey, sorry about that. I was actually running with the sweeper agent. I had an old repo. I ended up in less than an hour, I fixed all lint errors that I was avoiding for years. This is a project that has about 100 users on it. And I just couldn't be bothered to fix this project, but I was able to run a sweeper agent to clean it up and bring it up to modern standard times 6 months later, because it's a 6-month-old product. So this is like kind of like what we're thinking about with tapes, like their opportunity for collecting the trace data, but anomaly detection. So anomaly detection of like, hey, 10 tool calls had failures, like what happened? But another anomaly is actually success. So if you have 26 skills invocations, out of like 10 sessions, like there's probably something good happening there. And a lot of us are like, we're not even like looking with the fine-tooth comb of identifying anything of value. Like we're kind of just like shooting, again, we're shooting from the hip. We're like, cool, prompt me, no mistakes, clean code, go. And there's a lot of stuff we can learn for even if a simple prompt like that, there's a lot we can learn from that one prompt. So that's why it's important to keep these trace sessions. They unblocked me after the blog post took about 12 hours. Pretty amazing. It's all robots that answer your emails, but apparently the blog post was good enough. So we've been upstairs talking about this story about turning your dead tokens to skills. If you haven't quite got this concept yet, and I've kind of explained this, it's like, again, you're using tokens. You get a 5-hour window for every time you get a new refresh of like access to tokens. You get a weekly allowance of tokens, despite the fact that you're paying for this thing. You get a weekly allowance, and you can pay for extra time and for fast time. So even for situations where you're like, man, should I turn on Claude Code fast, or should I pay for overages? Like, is the value there? There's a lot of opportunity to understand that just by looking at the data. So I want to talk about this tape skills pipeline, and then I'll get to sort of the fine and tuning story in a sec and sort of wind this down. But tapes collect the sessions, generate skills. A lot of folks asked us like how this works. So my co-founder in the back, he's actually the one that designed all this stuff, but we have like a Merkle DAG. So if you know Git, every Git commit sits within a DAG, so you can go and have a hash for every commit that gets, and they have like these branches and like looks like this. So every session has turns. And I was talking about 1,000 turns within a session for like my Pokemon experience, but it's the same thing for your session. So every time you type Claude, Codex, Olama, whatever, that's your session. Your session has begun. Claude's a little weird where they start splintering sessions in a weird way, and they're like, we'll figure out how to like display that in like an observable way eventually. But consider this very rudimentarily. Each session you type Claude, that's your session. When you do clear, that's a new session. When you close it, you start again, that's a new session. So once you have the concept of like, cool, everything I've said in this session is now stored in a trace, now you can do some cool things of like, I've got the skill called check the tapes. So again, data stored on your machine for 30 days. I can go back 6 months and say, check the tapes. Like, how did we get here? Like, why did this happen? We can get blame, but who's actually using get blame? Cool, okay, well, we're using get blame, sorry. Well, I apologize. But I don't use Git blame. I haven't used Git blame in like 6 months because I've been building a bunch of tools that look like Git blame that perform much better. I built a tool called, on top of LanceDB, called Git Blamer, and it's just basically this. It was very bad. I wrote a blog post on it, but it wasn't great, so I don't use it anymore. But what I'm getting is I can check the tapes and say, hey, give me all the sessions that I like solve the door cooldown window for Pokemon. Like how do we like turn that into a story? What I did actually recently is I built an entire wireframe of our actual cloud product. And we have a designer who came on in the contract, and she's like, hey, can you share your prompts with me? And I'm like, I don't have my prompts. Like, who saves their prompts? And copy and paste. Like, you don't want to see my prompts. But I had the tapes. So I could say, hey, based on these wireframe, let's open up GitHub issues for every single feature. And then every feature has the prompt, it has the intent, it has a token usage. It has like all the quality of that a designer would need to then go take to design the product. And I had a very, very rudimentary wireframe. I'm a front-end developer by trade, but I sort of shad CN'd, prompt coded that thing to wazoo. But having a skill that's called check the tapes, I can go look at deeper into the database. And the way this works is also you have like all these sessions that have been sharded. And we have I say currently we're not labeling the data right now, but at the time we were doing this for Tape SQLite, we were labeling the data, so I could actually have labeled data of like, this is type front-end stuff, this is design stuff, which was super helpful. What I was showing briefly for folks who asked enough questions upstairs is Tape's deck. So Tape's deck was like, it's open source, there's no sign up. This is all built on the command line. And you could actually have a visualization or observability of your tape sessions. This is why it's called Tape's deck. And tapes to being the most durable form of media. So that I can see all my sessions, and then I can sort of click in and then see all the input-output tokens, all the prompts. Like, it's all the raw data. And I think a lot of folks have asked a question around, well, what if my prompt has sensitive information? Like, what if you didn't put sensitive information in your prompts? But this is all on you. So like, this is all your data, and this is all the data on your machine. So like, how you treat that data and how you sanitize it, like it's open for discussion in open source, but like for now, it's all pretty raw data. So don't put secrets in your Claude code. But we'll get there. So yeah, this is like this looking at every single, so it's hard to see, but these are all tool calls, these like cogs, and every pencil is a skill invocation. So like this is, you can actually visualize like how often skills are being called and how often tool calls are being leveraged. And this is actually documented in our, Tape's deck is documented in our documentation in Tape's dev. Tape skill is a feature that we haven't really, we have one blog post on it. We haven't spent a lot of time talking about it until here at this conference, but because we have everything stored in a database, I didn't mention it's also vectorized as well. So you can do natural language. You can say tape search, whatever string of text you're looking for, and it will bring all the sessions up of that search. So if you want to take that session, the output of all those sessions that you've searched and say, hey, create a skill. So, and this you could do with like a small model. I've actually been using, I'm a cheap person. So I've been using 4.0 as my main driver for models because it's a year old and it's super cheap. But you can generate a pretty decent skill like first pass. I do recommend that you do want a human to like go clean up like the skill itself and like go read it as a human with your human eyes to then identify if it actually you leverage. But once the skill's up, the skill works, it gets invoked, then you can use the tape sessions to identify how often it gets invoked or whether it's working. And then I guess you could probably get to the point where you use Tesla to identify a scorecard or whether the skill is actually useful, which I'd love to talk to the Tesla people about that next. But I say all this because I moved into, eventually we have skills, and now I wanted to go down this path of like, what if I train the model? I had the benefit of working at this company called Continue, where we trained a model called NextEdit. So back when tab completion was still cool, we had a model that we trained using specialized fine-tuning. It's the exact same way that Cursor Composer 2 has fine-tuned on your data. So if you're a pro user of Cursor, congratulations, your data is now being sold to SpaceX. But that same pattern is basically what I'll show you in a sec. So this is the blog post I wrote about this, and this will have more detail of what I'm about to go to. But I had 77,000 tape sessions. So this is me just starting to record as of January, and every single thing that I wrote, I was just recording in a tapes database. And what's super cool about this is like we're in London, right? This is like the home of Pink Floyd and Rolling Stones and the Beatles. Did I get all that right? Okay. Yeah. But anyway, like I play music, and what I really liked about the Beatles around this time is like they actually intently use less tracks. They would get everyone in the room and they just play live. And it's like I never grew up listening to the Beatles or anything like that until I got older. But it's gotten like this weird, like deep rabbit hole about this. But sometimes you can just do more with less. But right now I have a lot. So 77,000 tape sessions is a lot. It's about 4 gigs worth of data. We're doing about a gig of data a week. So if you're storing sessions on your machine, you got about 4 gigs. If you want to push that up to a year, you're probably like approaching 50 to 100 gigs of this data that's sitting on your machine that you've never looked at. And maybe a handful of us are like chatting with on Fridays. So the way I'm going to explain this is 2 different ways. Specialized fine-tuning, we're not going to go super deep. I'm going to mention some terms. You can go Google and read papers later. But specialized fine-tuning is the process that Cursor used for Composer 2. DPO, which is direct preference optimization, is a bit more specific. And the way I'll just like break this down is QLoRa is the tool that folks will probably use PyTorch or Unsloft with. And you can fine-tune, again, on your own data, and essentially do this. So if you think of a model like a book, So every model is a book. It's got like lots and lots of information. It's been like co-located into a place. This is why you can search for Pokemon and search for like good restaurants in the same ChatGPT session. SFT, specialized fine-tuning, is as if you were to write your skill in the margins of the book. So you're now adding extra context and extra notes into the book. Does that kind of make sense to y'all? Cool. So if you, I don't write a lot of notes in my book. I haven't been in school in a long time, so like none the wiser. I actually get kind of annoyed when I get a used book and it has a bunch of random notes. I'm like, who is this person? Why is this here? Maybe they were famous. I don't know. But that's specialized fine-tuning. And what I ended up doing is taking Quinn 4B, so it's a smaller model, and I got the idea of like, what if I embed the skill into a small language model? And the results are actually really good. So I'd say I didn't spend a lot of time, I didn't have a lot of data, and this is all my skills. Actually, this wasn't all my skills. This was me and 3 other team members' skills, and I was able to embed the skill into the model. Now, you're gonna ask the question, it's like, why would you embed in the model? And why would you not just use a skill and let it invoke by the harness? And I would say, why not? And I was really just going down this nerd snipe moment of like, I'm just gonna test it out. It's great work. It actually works pretty decently for a small language model on your MacBook or on your Lenovo or whatever, your Linux machine. Works pretty good. So think about the use case for this is like, it is the Pokemon use case. It is onboarding to a random project. It's onboarding into some random documentation that you have to go slog through. It's a very, very specialized small language model problem. It is not your daily driver. So like if you're trying to replace Claude Code, you will not. If you're trying to get Sonnet equivalent interactions, you will not. But if you're just trying to like prove a point and do a cool thing for something that's very bespoke, if you're working a lot of machinery or you're working with like weird languages that have bespoke situations like memory management, like this is an approach, and I've talked to a couple of enterprises who are approaching it in this manner. I will mention the DPO, which is reinforcement learning, which kind of looks like if you have 2 choices, it will always pick the best choice, no matter what. So this is actually really expensive, and I'll just get that out of the way. I don't recommend doing this ever, unless you're a researcher and you work at Meta. I don't know if that guy's here, but like this is probably a thing that costs a lot of money that you have a very expensive problem for, that you have. You've got reasons to use this. And I say this because I was actually doing this all on a 4070 RTX, so local gaming rig, specialized fine tuning works perfect. This could not run. It needed 24 gigabytes of VRAM. I needed 32. I had 24. So I had to upgrade my, I'd upgrade to a 32 gigabyte 5090, which I shamelessly did. And the results were basically middling. So lucky enough, I actually got a friend who was at NVIDIA. I will not name their name, but I did get some H100s. And the other thing I was mentioning is it's like Cliff Notes. So if anybody use Cliff Notes, is that a thing here in, are we just American dropouts? We do use those things. So Cliff Notes, if I explain this is the book you get instead of reading the actual college textbook. So you will get the Cliff Note, and then you'll take the test. Not recommended, but it's like if you just want to skip the line and to like just take the test and learn the Cliff Notes. So that's what DPO is. That's fascinating, this culture shock here. This is why university costs so much in the US, because we cheat. So results, DPO on a 4 billion parameter, not good, not even worth it, don't even try. Gonna be like expensive, like you'll probably spend like $1,000 a week in compute just to get something that doesn't even work. On a 7 billion parameter model, yeah, go for it, but also very expensive. So I actually was just doing this because I knew I had this talk and I wanted to like kind of round out this talk into a conclusion. But what I'm doing next is I'm actually meeting with folks who actually know how to do research, and we'll figure this out together. But this is more of a side project, side quest for me. So with that said, DPO, all right. All it does is pick the right selection every single time, all the time. Anybody watch this movie? It's just an American culture thing. It's just the American in the back. Cool. All right. Matthew McConaughey, one of his earliest movies. It's a quote. It's a meme. So basically, well, I'll round this out, is like, step 1 is capture the sessions. Like, if you leave this room today, go look at .claude/sessions and start using them. If you want to start collecting data and pull it off your machine, tapes.dev. It's open source. Definitely leverage it. But the next step is knowledge transfer. So the best part about this is multiplayer coding sessions. So multiplayer as in the sense of You're all solo player on your machine, local. If you have a second machine, you're probably not transferring the data back and forth. Let's get to the point where we can actually transfer that knowledge, and that transfer of the knowledge actually looks like skills. It's probably the best way to do this. And then you now move into a place where you unlock the hardest freedom. So if you're using Claude Code and you want to use Codex because Codex turns out to be better this week, you can just transfer the skills over to Codex or PyCoder or anything else. But we have the option. We have optionality to do this. I know as of today, Anthropic's going to IPO in the next couple of months. They just announced their SEC filing. I'm going to read it on the plane ride home. My background is finance. I went to school for finance, so that's my guilty pleasure, so reading SEC filings. But the next thing is model choice. At that point, you don't need Opus all the time. You can use Haiku. You can use some random Chinese model. That's an opportunity. And then eventually we'll start, the other shoe will drop, and we'll have to think about cost. So trace the data, reinforce with learnings, find this in Expo Hall. That is me on BDougie, and I think I have that slide. This is me on the internet. Thank you.
Thank you so much, Brian. We have 1 minute if anyone has a rapid fire question for Brian.
Hi, Brian, thanks. Does tapes.dev work for Codex, or is it just Claude Code?
Yeah, that's a great question. So today it does not work for Codex. It worked at a moment, but things change quickly. So we currently today work for Claude Code, Conductor, and Olama. We're more than happy to make it work for Codex. Someone needs to say they need it. That's pretty much the only limitation.
That is all the time we have. I'm so sorry, but Brian
I'll be outside.
Is at his booth as well, so catch him, ask him questions, hunt him down. He'll be here all day.